Okay, for 81, we have a square root on both sides of the equation. So how do you get rid of the square root? Well, you square both sides. So we have 11h is equal to h minus 20. Alright, so here I subtract h, and I get 10h is equal to negative 20. Divide by 10, and h is equal to negative 2. Now when you square both sides of an equation, there's the possibility of introducing an extraneous solution to the problem. So what you have to do is plug the solution you got back into the original problem and see if it works out to be true or not. So I have 11 times negative 2 is equal to, negative 2 minus 20. And I end up with negative 22 is equal to the square root of negative 22. Alright, now you might say that that's true, but what's not true is that you can't take the square root of a negative number. So there is no solution for this problem. Alright, cannot take the square root of a negative number. That's a no-go. Alright, next problem. Alright, here I'm just distributing. I have 6k minus 12 plus 3 is equal to negative 5k. And then I have negative 2k minus 8. Alright, just be careful adding like terms. Negative 12 plus 3 is negative 9. Then I have negative 5k minus 2k, which is negative 7k minus 8. Alright, so I add 7k to both sides. So I get 13k is equal to, if I add 9 here, alright, I normally like to write out each step, but I'm just going to condense it right now. That's 1, so I divide by 13, and k is equal to 1 over 13. Done, and on to the next. Okay, solve for w. Alright, so first thing I'm going to do is subtract 2l. So now I have p minus 2l is equal to 2w. And I'll divide by 2. So now I have w is equal to p minus 2l over 2. Done. That's all there is to it. Alright, the length of a rectangle is 2 inches more than 3 times the width. Okay, we have a rectangle, width, and length. Alright, the length of a rectangle is 2 inches more than 3 times the width. Okay, so 3 times the width, and 2 inches more would mean plus 2. Find the length and width if the area is 85 inches squared. Okay, area of a rectangle is length times width. I know the area is 85, and the length is 3w plus 2, and then times w. Alright, so I'll distribute here. I get 85 is equal to 3w squared plus 2w. Then I'll subtract 85. And these are all unlike terms. So 3w squared plus 2w minus 85 equals 0. Alright, now I'm going to factor. And since this value does not equal 1, it's going to be big X with grouping. So I need to find two numbers that add up to 2 and multiply to give me negative 255. Right, you may have to think a little while to figure out what combination of numbers work, but it's going to be negative 15 and 17. Alright, since I'm doing big X with grouping, now I take the first term, 3w squared. I take the middle term, break it up using these two values. Subtract 85, and it's equal to 0. Now I group. Alright, so the first group I could factor out a 3w, leaving with w minus 5. The second group I could factor out a 17, leaving with w minus 5. Okay, so I have w minus 5 then, and what's left over is 3w plus 17. Alright, so I have w minus 5 equals 0, and 3w plus 17 equals 0. Alright, I add 5, w is equal to 5, and I subtract 17, we get 3w is equal to negative 17. Divide by 3. W is equal to negative 17 over 3. Now we can't have a negative width, so that can't be a solution. But we have our positive width here. And it's also asking me to find the length. So all I have to do is plug W back in to this equation. L equals 3W. W is 5 plus 2. And I get length is equal to 17. Alright, so the width is 5. The length is 17. Done. Alright, solving this absolute value equation, there's always a positive case and a negative case. So just work those two cases out and you'll have your solutions. Alright, so one of the solutions is 6. And the other solution is 2. Alrighty, done. For the next one, we have to solve. All right, you could use substitution, you could use elimination, whatever you want to use. Here I'm going to isolate y. So y is equal to 3x minus 3, right? If we add 3x over. Okay, so I'm going to take this and plug it in for y over here. So I have 5x minus 2 times 3x minus 3 is equal to 10. All right, distribute, and I get 5x minus 6x plus 6 is equal to 10. Then I get negative x plus 6 is equal to 10. Subtract 6. I get negative x is equal to 4. Divide by negative 1. And x is equal to negative 4. All right, that's one of my values. I'll take that and plug it in here. And I get negative 3 times negative 4 plus y is equal to negative 3. So I have 12 plus y is equal to negative 3. And subtract 12. And I get y is equal to negative 15. So that's my answer. Negative 4, negative 15. That's this question. Solve. They make this really easy for us. Just plug 4x in for y here. So I have 6 plus 6x plus 2 times negative 4x is equal to negative 3. So I have 6x minus 8x is equal to negative 3. So now I have negative 2x is equal to negative 3. Divide by negative 2. I get x is equal to 3 halves. Alright, now I take that and I'll plug it back in. So I get y is equal to negative 4 times 3 over 2. Alright, and the 2 will cancel out the 4, leaving me with 2 on top, and I get y equals negative 6. So my answer is 3 halves, and then negative 6. Done. Graphing y equals the square root of x minus 5. Now for this type of problem, if you understand how to work with these really well, one of the strategies is to understand that whatever number you have inside, that's the number you move along the x-axis, but in the opposite direction to get the x value for the starting point. And then whatever we have added on outside here, that's how far we move up or down. So since this is negative 5, I do the opposite of that. So I move over here to 5, and it's 5, 0. My y value is 0. So that's my starting point. And if you're familiar with what the graph of the square root is supposed to look like, it sort of looks like the radical itself, sort of like a wave. Okay? So then from here I know I just move to the right like that. It's going to have that type of graph. Now if you want to be more precise, you can create a t-chart and say you didn't know anything about what the graph of the square root is supposed to look like. Then you just create your t-chart, and this method always works regardless of what type of graph you're working with. So I'll choose -2, -1, 0, 1, 2. Now these numbers typically work well with a quadratic, but we're working with a radical or square root function here. And if we plug -2 in, I get -7, and the square root of -7 we can't do. We can't do the square root of -6, we can't do the square root of -5, -4, 3, -2, -1. We can take the square root of 0 though. So I have to move up a little more with my numbers here. 3, 4, 5. That's the first number that's going to work. That when I plug it in, I can take the square root of it. So the square root of 0 is 0. If I plug in 6, I get 6 minus 5, which is the square root of 1, and the square root of 1 is 1. And you could continue this, all right, and you'll get more points along the grid. But I have 5, 0, which is what I had right here, and then I have 6, 1, which is right here. Okay, so there's 2 points. And then from there you can just plot more points and you get a more accurate graph. But it's much more simple if you know what the graph of a radical is already supposed to look like. All right, so there's 2 strategies to solve this problem. All right, solved by graphing. Here I have 1 over 1 for the slope. Y-intercept is -3. Then 1 over 1, so up 1. Applying my slope. Alrighty. And then I have 2 over 1, and then -1 as my y-intercept. So I go up 2, right 1, up 2, right 1, up 2, right 1, down 2, back 1, down 2, back 1, down 2, back 1. Alright, I'm solving now. Where did they intersect? Right there. That's -2, -5. That's my solution right there, where they intersect. Alright, let's graph once again. Alright, here I have a slope of 1 over 1, starting off at -3. So I go up 1, right 1. Alright, and you'll notice that it says less than, so that means it's a dashed line. And it says less than, so I'm shading below. Okay. And then I have 2 over 1 here. -1 is my y-intercept, and I go up 2, right 1. 2, right 1, up 2, right 1, down 2, back 1, down 2, back 1, down 2, back 1. All right, and there's my graph, and it says less than once again, so I'm shading like this. And that means my solution is this region here, where the shade regions overlap. All right, that's all there is to that. Done.